Okay, so this part again is called the discriminant. I'm going to set that equal to, basically, like I said, it has to be equal to or greater than 0. So I'm going to turn it into an inequality, okay, to figure out what numbers will work. Now, I don't know what B I'm going to use, but I already know what A and C is. So I'm just going to fill in that part of the equation. So A is 5, C is 20. Okay. So now I'm just going to kind of work this out. So 4 times 5 is 20 times 20 is 400. Now we're solving for B. So now I'm going to add 400 to both sides. So I get B squared is greater than or equal to 400. I'm kind of move this to the side here. Now, when you are working with square roots and inequalities, the next step is to square root, right? Square root. So I get B is greater than 20. The only thing is when you square root, there can be more than one solution, okay? So, but when you're dealing with the inequality, it's a little bit different, okay? Because basically, if I plug in, let's say, negative 20 squared right here, negative 20 squared is 400. But positive 20 squared is also 400. So it could be positive or negative. The way we account for that in inequalities is you put an absolute value around the B. Okay, and now we're going to basically solve this like an absolute value. Again, this is why I'm doing this with you guys. Okay, I'm kind of pretty much giving the answer on this one because I know that we didn't really get a chance to go over how to solve quadratic, in other words, ones with square and inequalities. So now I split that into 2. So now 1 will be B is greater than 20. And when I split the second one, I flip the sign, which is now less, and I change the last number. Okay. So basically, that's what B can be. B can be greater than or equal to 20, this number here, or it could be less than or equal to negative 20. So any of those numbers would work to make sure that the solution is real, okay? Okay, now this with logs, okay, just a reminder on this one, when you have, that's asking you to combine them. It's asking you to like put them together. When you have a number in front, before I put the 2 logs together, I want to take that number in front away. Do you guys know where to put that number? Or where I can move it to? So this number right in the front, this 8 or the 9 here, where can I move that to so it's out of the way? Where, on top of what? On top of the, no, not on top of the 2x. On the what? Yes. So I move it to the exponent. Okay, so I can move it to the exponent. Now it's log base 3 of y to the 8th. Now I can combine the 2 a values. Now I can combine, and how do I combine it when it's plus? Well, I combine this, the y to the 8th and the 2x. How do I combine them? You multiply the 2, okay? So this way you would turn into one log from that by multiplying. Now here, do the same thing. This becomes log base 4 of what? N to the 9th power. Basically, again, I just moved that number in the front to the exponent on the a, okay, or the a value, whatever this number is, okay? And then I'll combine that. So again, these are two different problems here. Now, when I combine these two, how do I combine the 5 and the 9? Right, division because of the minus. Okay. Okay, so that was from yesterday's packet. Just wanted to kind of review that. Now for today's work, or today's topic, and let me give you guys just a second. I want you guys to, all right, so we're looking for X and Y. Now, before you even start these problems, you want to set up a ratio. Okay, now, what we know about triangles like this, when it's a 90, a 60, and the last one is, which is now 30. Okay, it's not written, but once you see 60 and 90 in one corner, you already know the other one is 30 because they all add up to 180. Okay, they have a special relationship. Each side has a special relationship, and it always holds to like a certain like scale or ratio. Okay, so if I know one side, I can use that ratio to figure out the rest. Okay, so this is the ratio, and it's always the same. So if I have a 30-degree angle, a 60-degree angle, and a 90-degree angle, the ratio between the sides that are across from those angles is, for 30, it's 1. For 60, it's going to be Brad 3. Okay. And then for 90, it's going to be 2. Yeah. Okay, so it'll always be, and again, what this is referring to is the side that is across from that angle has this ratio. So basically what this means is if I'm comparing, let's say, the side that's across from 30, so let me just fill this in. So this is 30 degrees, right? So the side across from 30 is Y in this case. This is straight across. So I'm going to put Y right underneath. The one under 60, or across from 60, is 2. And the one across from the 90 is X. So what this ratio means is that if I'm comparing Y and X, X is twice as big as Y because it has a 1-to-2 ratio. Okay, or the other way around, Y is twice as small as X because of this 1-to-2. And then the ratio here is the square root of 3, which is a little less than 2. It's like 1.7. So that's the ratio that these two share or these two share. Okay, so it's just the relationship between those. Now, if I'm looking for X and Y, what I do is I need to take a combination of these, of a ratio, size, and the side itself. So if you look at these two to start with, they're complete. Like there's no missing side. There's no like variable here. They're complete. It's a complete pair with the ratio and the side itself. So I'm going to use this to help me find the other two. All right, so what I'm going to do first is I'm going to take these two pairs and create an equation. So I'll do 1 over Y, and then I take square root of 3 over 2. Okay, and now I've created a proportion to help me solve for Y. Okay, so first step here, I'm going to cross multiply. So Y times the square root of 3, and then 2 times 1. And again, I'm solving for Y, so I'm going to divide the square root of 3 on both sides. So that cancels out that square root of 3 there. The only thing here is that the rule, when we're writing out exact values, the rule is should not have any radicals or square roots in the denominator. So no radicals in the denominator. So basically no square root should be in the bottom of the fraction. So what we do to get rid of that is we do what's called rationalize. So rationalize just means to get rid of that square root from the bottom. So to show you how to get rid of that, I'm just going to give you some examples. If I do the square root of 2 times the square root of 2, that's going to be equal to 2. Or if I do the square root of 5 times the square root of 5, that equals 5. If I do the square root of 7 times the square root of 7, that equals 7. And so on. So basically, if you multiply two square roots and they're the same number, it's just equal to that number itself. Okay. So to get rid of this 3, I'm going to multiply the top and the bottom times the square root of 3. Now that's not going to get rid of anything on the top, but it'll cancel out the square root on the bottom. So I'm multiplying top and bottom. So now y is equal to, first of all, the top is 2 times radical 3. And the bottom, since I'm doing rad 3 times rad 3, it's just equal to 3. Okay, so again, I'm just canceling out that radical there. Okay, now the second one. So now we're going to look for x. So now, from the ratio, I just take these two pairs. So I take the other, I'd use the same one, rad 3 over 2, but now I'm going to use 2 over x. So now rad 3 divided by 2 equals 2 over x, cross multiply. So x times rad 3 is x times rad 3. 2 times 2, 4. Same step like over here, divide by rad 3. That cancels out. And then rationalize, just like we did on the last one. So I'll multiply square root 3 times square root 3. The top is just 4 times square root 3. And then the bottom, the square roots cancel out, and I have just 3. So there's y, and there's x as an exact value, or simplified. Even though, to be honest, it doesn't really look simple. Okay, simple would be just turning it into a decimal. At least to me, that would be. Okay, so I'm going to just do one more. All right, so let's do. Okay, let's do a 45-90 triangle. 45, 45, 90. Okay, so we're going to do the same idea, except this time instead of doing a 30, 60, 90, it's going to be a 45, 45, 90. Okay, same idea, just different ratios. Okay, so that's 45 degrees, that's 90, which means the last one will also be 45 degrees. Okay, and we're solving for m and n in this case. Okay, now the ratio for 45, 45, 90 is 1 to 1 to radical 2 or square root 2. So that's the ratio relationship for this triangle. Then I say, okay, the side that's across from 40, 45 is m, and the other 45 is also n. So, and by the way, notice this is a 1-to-1 relationship, meaning they'll be equal. So if I find one of them, I already know the other because they're going to be the same. So I don't have to look for it twice, in other words, because they'll always be equal. And then the last one here is a 9. All right, so basically, I only have to do one step here. I only have to find either m or n, and then I'm done, because that will give me the other side. So I'm going to use these two, or these two pairs. Here's the known pair, because I know the ratio and the side. And we're just going to set up the equation. So now 1 over n equals radical or square root 2 over 9. Again, cross multiply. So n times radical 2 1 times 9. Just like before, divide by the square root. Now again, there's a square root on the bottom, so I got to rationalize. So what do I multiply on the top and the bottom? Yep, radical 2 on the top and the bottom. So now that cancels the first part, square root 2 over square root 2. And then I have n equals 9 times the square root of 2 on the top. And then again, square root of 2 times square root of 2 is just 2. Now the next thing I want to do is check the numbers on the top and the bottom. Can I divide them? Like 9 over 2. Do they have a common factor? Well, in this case, no. Or 4 over 3. Do they have a common factor? 2 over 3. Do they have a common? Because you can divide those, but in this case, I can't. Okay. So that is also m. So I'm just going to put m and n equal 9 times rad 2 over 2. Okay. Okay, so I just want to give you guys some examples of kind of the harder ones, at least the ones I figure are usually a little bit harder because you have to do the rationalizing step at the end. The rest are usually you're going to get some kind of whole number, or you're not going to have to at least rationalize it at the end. Okay. All right, and that is pretty much the packet. The last part of the packet for the rest of the assignment just involves division. So you can use synthetic division or the box there, which, and then use your answer to solve, which just means you're going to have to completely factor. Okay, so here, use synthetic division, okay, to solve, to first divide. And then again, use that. Okay, this is the last problem in the packet. And then use that. Let me see, where should I write this? Use, actually, I probably won't need to. Now that I'm seeing that that starts with the degree of 3, that means your next factor will be x squared, which probably means you could use the quadratic formula or factoring to solve. Okay, so that's the last step. The rest of the problems on this are just the triangle problems for the whole packet or that whole homework assignment. Okay, you guys at home, if you need to copy the rest of the notes, you can stick around. Otherwise, I'll see you guys tomorrow.